Okay, welcome everyone. So in this video, we are going to take a look at an example, a nice concrete example where we have a 3 by 3 matrix A, where the first column is 6, 3, 2, the second column is -3, 0, 2, and the third column is 1, 5, 6. And here we want to check, is 5 an eigenvalue of this matrix A? So first, let's just recall one of the conditions that we can check to see whether lambda is an eigenvalue, in this case lambda equals 5, is we would want to look at the matrix equation A minus 5 times the 3 by 3 identity matrix times some vector x equals the 0 vector. What's going to determine whether 5 is an eigenvalue of this matrix or not is going to be whether or not there is some non-trivial solution to this equation for x. So this vector, a minus 5 times the identity vector, is what we're going to get when we subtract 5 from each of these diagonal entries and nothing happens to the off-diagonal entries. So in this case, the resulting matrix, we take 6 minus 5 gives us 1, 0 minus 5 gives us minus 5, and 6 minus 5 gives us 1. So here's the vector A minus 5 times the identity matrix. And so we'd like to know what are the solutions to this homogeneous matrix equation. So we can set up an augmented matrix, which I've got over here. And then we can take this matrix and do row operations and write it in its reduced row echelon form, which I've got over here. And so notice that x1 has a pivot, x2 has a pivot, x3 has a pivot. There are no free variables, so the only solution to this equation is x1 is 0, x2 is 0, x3 is 0. So this equation has only the trivial solution. Vector x is equal to the 0 vector is the only solution. So when we have only a trivial solution to the equation ax is equal to 5x, that means that lambda 5 is not an eigenvalue of matrix A. This equation ax equals lambda x has to have non-trivial solutions for lambda to be an eigenvalue. And so when we set lambda equals 5, we found that there's only the trivial solution. So this is not an eigenvalue of matrix A.